In this video, we will cover section 10.1 in Math 94, which talks about properties of exponents. This is like homework number 7, problems 7, 8, 9, 10, 11, 12, and 13. Now, we've done a lot of work with exponents, but let's kind of just review some terminology. You might recall when we have a problem like 10 to the 4th power, that 10 is called the base and 4 is called the exponent. And that this 10 to the 4th power is really just a shorthand for saying 10 times 10 times 10 times 10. Oftentimes in algebra we see this with a variable as the base. We might say x to the 5th power is x times x times x times x times x. We're going to develop some rules for exponents. I'm going to explain why they all work. When we get done with this, we're going to apply these to some problems. These rules for exponents are useful as you continue to work in algebra. The first rule is x to the a power times x to the b power equals x to the a plus b power. Here it's important to note that these are both the same value. So two things with the same base multiplied together, you add exponents. Let's see why. X cubed, you might remember, is x times x times x. And x to the 4th is x times x times x times x. Now, if you look at this, you'll notice that there are x7 there. There are 7 x's multiplied together, so that's x to the 7. What's the relationship between 3 and 4 and 7? It's addition. Here's another rule. X to the a to the b power equals x to the a times b. Another way to say that is if you have something raised to a power raised to another power, you multiply the exponents. Let's see why. X squared to the 3rd power. Well, this 3rd power means take whatever is inside of here, multiply it by itself, so that there's 3 of them. Now, if you look at this, it's not too hard to see there's 1, 2, 3, 4, 5, 6. So that's x to the 6. What is the relationship between 2 and 3 and 6? It's multiplication. Here's the last rule to start us off. X times y raised to the a power is x to the a power y to the a power. To see y, take a look at this problem. Again, 4th power, remember, means xy times xy times xy times xy. Now remember, this is all multiplication here, so I can move all the x's together, and I can move all the y's together, and that's x to the 4th, y to the 4th. You'll notice it looks like this 4 kind of distributes in there. You've got to be careful about that word, but basically this power is applied to every term multiplied together in there. Okay, let's do a few practice problems. X to the 7 times x to the 8. Here, I have the same base, so I'm just going to add the exponents and get x to the 15. Sometimes we have variables. That's okay, same idea. Y to the 3rd and y to the a is just 3 plus a. And a to the n times a to the 5th is just a to the n plus 5. How about this one? Well, this is that second rule. Multiply the product here, and you get 12. Now, you got to be careful about this one. 2x to the 4th to the 5th really means 2x to the 4th times 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 2x to the 4th. How many 2's do I have? I have 5 of them, right? How many x to the 4th do I have? I have 5 of them. So really, I could use that first rule where I apply the 5 to everything multiplied together in here. This is 2 times x to the 4th, so that's 2 to the 5th times x to the 4th to the 5th. Now 2 to the 5th is 32, and x to the 4th to the 5th, again, that's like this one. I'm going to multiply the exponents, and that's going to give me x to the 20th. Okay, last one. Let's do this using that last rule. Instead of multiplying this out, writing this out 3 times like I did the one above it, I'm going to say that's 3 to the 3rd times a cubed to the 3rd times b 4th to the 3rd That's 27 times a to the 3 times 3 is 9, and b 4 times 3 is 12. So 27 a ninth b 12. Time for some more rules. Here's a rule. X to the 0 power equals 1. Anything other than 0, I should really say that, x can't equal 0 here, to the 0 power equals 1. Let's think about y. Well, think about x cubed times 1. That certainly equals x to the cube, right? But if we wanted this to be x to a power, what power would it be? Well, x to the third times x to what equals x to the third? Since you add exponents here, this had better be 0. So anything to the 0 power is 1. Even if I write something down real complicated like this, and I go like this, and that s5 over t7z cubed to the 0 power, that just equals 1. So that's kind of what we got going on there. Now let's take a look at another rule. This rule is a little interesting. It kind of uses that idea of x to the 0 equals 1, so I wrote that up there again. But x to the minus 1 time equals 1 over x. To see why, we know x times 1 over x is equal to x to the x, which equals 1. If I want to write this in terms of exponents, I know that 1 is x to the 0. And I know that x is x to the first. What does this have to be? What does this exponent have to be in order for this to work? Since these have the same base, these exponents would have to add to 0. Since this exponent is 1, that one better be minus 1. So x to the minus 1 equals 1 over x. You can generalize that by saying x to the minus n equals 1 over x to the n. Again, if you look at this, you have x cubed times 1 over x cubed. That's x cubed over x cubed, which again is 1. You could say that's x cubed times x to the what equals 1, but 1 is x to the 0, so this better be negative 3. So usually I just refer to this rule. It kind of includes that one too. Let's look at some examples. Okay. Here, 5x to the minus 1 is, well, the x to the minus 1 only applies, the minus 1 only applies to the x. So this is 5 times 1 over x, which is 5 over x. Now let's do a few other rules. X over y raised to the a power is x to the a over y to the a. This is a lot like the multiplication rule. If you take a look at this, x over y cubed equals this. This equals x times x times x, which is x cubed, y times y, which is y cubed. Okay? So that's kind of like that multiplication rule we had earlier. And here's a very useful rule. X over y to the minus n equals y over x to the n. In other words, if you take a fraction and raise it to a negative exponent, you flip the fraction and make the exponent positive. It's a little confusing to see why, but let's try it. We know that a negative exponent means 1 over that item raised to the negative exponent made positive. So this equals this. Now this can be rewritten as 1 divided by x over y squared. If you believe the rule I wrote above, 1 divided by x over y squared is 1 divided by x squared over y squared, which is 1 times y squared over x squared, which is y squared over x squared, of course, because I'm just multiplying by 1, which is just this. So look at this and look at this, and you'll see that that rule kind of applies. I've taken all these rules and taken the liberty of writing them all down right here. So this is kind of useful to have handy, have a little chart like this handy as you're working on these problems. Now I'd like to try some harder problems here that work with this. Okay? So, 2a squared over c to the negative 3. Using this idea here, I can write this as c over 2a squared to the third, which is c to the third over 2a squared to the third. That I have from my rule up here, right? Now, that gives you c to the third over 2 to the third times a squared cubed. That rule right there is just applying this right here. So simplifying this out, that's c cubed. 2 cubed is 8. A squared cubed, using this rule, is a to the 6th. Okay? Here's another one to try. You might want to try this on your own, and then restart the video when you are finished. Okay, let's take a look. I'm going to take that minus 2 again. Flip the fraction, make it a positive. That's c squared squared over minus a squared. C squared squared is c to the 4th. Minus a squared, notice this is minus a times minus a, so that negative sign goes away, and I just get a squared. One other rule that you could apply here is x to the a over x to the b equals x to the a minus b. This is useful if you just think about a few problems like this. X to the 5th over x to the 3rd. Well, you know x to the 5th equals this, and x to the 3rd equals this. And you also know that this bar means divide, so these guys would disappear, and you're left with x times x, or x squared. What's the relationship between 5 and 3 and 2? Well, x to the 5 minus 3 equals x squared. It also works if you have a problem, say, like this. X to the 4th, of course, is x times x times x times x, and x to the 7th has 7 x's. Now again, this is all multiplication. This fraction bar means divide, so I'll get rid of those. And I have a 1 up here over x cubed. Now another way to write 1 over x cubed is x to the minus 3. So you can see that x to the 4 minus 7 is minus 3, which is the same as this. Now we don't normally write it with a negative exponent. We usually write it this way. Now, let's put these all together, all of these rules together in some of these examples. 4 divided by a to the minus 3. Well, that's 4 times 1 over a to the minus 3. What is 1 over a to the minus 3? Well, if I think about 1 over a to the minus 3, it's 1 divided by a to the minus 3, which is 1 times 1 over a, 1 divided by, a cubed. That a to the minus 3 is just a cubed. Now, when you divide fractions, remember, you multiply by the reciprocal, and I get this. Now you notice that a to the minus 3 now kind of came up in the numerator and became positive. And that's a shortcut you can take. If you have a problem where you have a negative exponent in the denominator, you can move the term with the negative exponent into the numerator and make the exponent positive. Let's take a look at this. Very complicated problem. 16a cubed b to the minus 2 over 4a to the minus 1 b to the minus 5. This is a cubed over a to the minus 1. This is b to the minus 2 over b to the minus 5. Now, a couple of different ways you can do this, but here's one way. 16 over 4 is 4. A cubed and a to the minus 1, those have the same base, so I'm going to subtract those exponents. 3 minus negative 1. And b to the minus 2 and b to the minus 5, I'm going to subtract those exponents. This ends up being 4 to the a3 plus 1, or fourth, and b to the minus 2 plus 5, or b to the third. So that's a way to do that problem. As a challenge, see if you can do this problem on your own, and start the video when you're done. Okay, I'm going to use that property of multiplication, that I can take that minus 1 and I can apply it to each term multiplied together here. So this is x to the minus 1 to the minus 1. If you know your rules of exponents, this you multiply minus 1 times minus 1 and get 1. Y to the fourth to the minus 1 is y to the minus 4. That answer is correct, but usually it is preferred for you not to have a negative exponent in the answer. So you'll write y to the minus 4 is 1 over y to the fourth, and finally x over y to the fourth. I hope you find this video useful.